Hello everyone. For my capstone, I looked at the observed differences in woodland characteristics of fenced versus unfenced woodlands in Mississauga, Ontario. My supervisor was Danijela, and my external supervisor was Sarah, who unfortunately couldn't be here. But it doesn't work. Tony. It doesn't work. No. All right. Thank you. Okay, so my internship was in Mississauga, and this was part of the VSP Collaborative Monitoring and Research Project that Danijela's team is undertaking with partnership with the Ministry of Natural Resources and various municipalities around GTA. And so for my internship, I did it in Mississauga, where they're currently doing the inventory of their woodlands. And so these are some of the modules that that I had to do for the Mississauga monitoring. Basically, you're looking at every single different vertical strata, and you're doing an inventory of everything, all the biological features as well as abiotic features that are there, except for soil features. So overall, this is what I did over the summer, and that's where the data for my capstone came from. So before I go more into my data, for those who don't know, this is Mississauga. It's located right near Toronto, and it's a large city. It's similar in species composition and weather to Toronto. So before we go more into my capstone, I would like to talk to you guys about fences. So I'm sure that fences is not the most exciting feature of a landscape you think about when you think of a woodland or something. At least for me, that was never the case. Until now, it's really exciting. So for fences, they're used for various reasons in a landscape, some of them being reducing human-animal conflict, separating invasive species from natural areas, providing a clear ownership of natural capital. For example, various municipalities and other government bodies would use this as a way to separate public land from natural land, as well as creating these management units that are easier to implement their strategies on. However, as much as there are benefits to fences, there are also various downsides. Some of the costs that are involved with fencing is from financial cost, as well as the cost of maintenance, as well as the ecological costs that are unintended, but you end up with these barriers to movement of other species that you are not intending to stop the movement of. And there's this other conflict that you don't really think about, but the public rarely take fences seriously. I did not know that until I went into this capstone project or this sampling. So for Mississauga especially, they have various woodlands that are fenced to keep out people from entering these woodlands, because these are these sensitive woodlands, and having people constantly going in is damaging for the woodlands. And for a long time now, which they're not sure of how long they've been doing it, they would fence off these areas to keep the public out. And a lot of people are not happy about this, because for them, this is a public area and they want access to it. So whenever City of Mississauga has to make this decision of whether to fence a woodland or not, they would always have to go through the pros and cons to try to see if this is worth fencing or not. And that's where the rationale for my study came for, is to see what are the current differences in these different woodlands that are fenced versus unfenced, to see if it is worth fencing, even though you have to go through this fight with the public to do so. Initially, I wanted to look at if these differences are caused by fencing, but because of the study design not being created for answering that question, I had to formulate it in a way to simply looking at a snapshot and comparing what is currently there and seeing what are the characteristic differences. And so the different characteristics that I looked at are outlined as objectives. Some of those are that I decided to look at the species diversity, species evenness, and species richness between the fenced and unfenced plots for all the different vertical layers, as well as I decided to compare the species composition of the regeneration layer and the tree layers using the DBH modular dataset. I then decided to perform a native to non-native species analysis for the regeneration layer as well as the tree layer. And next, I did a tree species size class distribution. And lastly, I did a comparison of the distribution types that are found in woodlands that are fenced versus unfenced. So here you can see that this is a map of Mississauga, and the yellow polygons are the various woodlands that are located in Mississauga. Mississauga has lots of woodlands, but they're very fragmented and separated all over the city. So as a result, the city of Mississauga wanted to have a representative sampling of all the woodlands, so they're doing one plot per woodland. So that's what that has been done over the past 2 years, where they did one plot per woodland. So this is the large data set that's part of the whole VSP study research project. And from this large data set, I took a subsample of the data set for my own study. And to create a subsample of the data set, I had two criteria. The forest sample or a woodland to be selected, it must be located on a tableland, because you can't be comparing a tableland plot and a valley land plot. And the second criteria was that the vegetation type of this woodland must be similar to a mature sugar maple forest type. And the reason for this was because when I was doing a preliminary research on the types of ecological systems in these fenced woodlands, they happen to be similar to sugar maple forest types. So even when I'm selecting unfenced woodlands, I wanted them to have the same ecological type so that I could account for this difference. So ultimately I ended up with 22 plots, 11 of which were sampled in 2018, 11 were sampled in 2011, among which 8 of them were fenced and 14 were unfenced. Unfortunately, I could not find that similar, because fenced plots are hard to find. But overall, when you're looking at this graph here, it's basically showing the different forest types that are present in the different woodlands. And in the unfenced, you have this sugar maple, so they're overall all different sugar maple types of forest. And so there is a similarity, and so I was okay with comparing these. So I'll be walking you through, guys, through the results. There's a lot, so I'll try my best. So for my first objective, which was to looking at the species diversity, I compared the canopy layer, the species diversity, richness, and evenness for canopy layer, subcanopy layer, shrub layer, and the ground layer. And overall, none of them are significant. Great. Except for the canopy layer. For the canopy layer, the average evenness is significantly higher in the fenced plots compared to the unfenced plots. Does it mean anything? Hard to say. But overall, there is no significant difference in the species diversity, evenness, or richness. But whether or not this is because of fencing or not is hard to say, because the study was not designed for that. And even if it is supposed to have a impact, because these are biological systems, there could be a time lag that is not being accounted for in this current time, because it's a time step. The second analysis I did was looking at the species composition, and this was for all the different tree species found in a single plot, and so I grouped them based on whether they're fenced or unfenced. So from here, you can see that and these are based on the Bayer codes, which are basically a form of creating this code where you take the first 4 letters of the genus and the first 3 letters of the species to create these codes, which are unique to each species. So overall here, you can see that in the fenced plots, the majority of species are Acer sass, which is sugar maple. Makes sense. These are sugar maple dominated forests. So that's great news. They are sugar maple. And the second most dominant species is Osterver, which is ironwood. And the most dominant non-native species in the fence plots is European buckthorn, which is the case everywhere. And when you're looking at unfenced plots, it's similar in that sugar maple is the dominant species, but it is actually the majority of the species. So in the unfenced plots, you have a lot less evenness compared to the fenced plots, but well, there is no significant difference, so I can't really say much about that, but overall, this is the pattern you're seeing. And this was interesting when I looked at what was coming up with the regeneration layer. So this is the regeneration layer, which were based on the subplots, which were 1 meter by 1 meter area. So in a 1 meter by 1 meter area, you're seeing this type of species composition coming up. So if you're extrapolating over a whole plot, you would hopefully still see a similar pattern. But what's happening is that in the fence plots, you have the sugar maple coming up, which is great news, and it's 30% of the species. So here you see that in the whole plot, you have this 28% of the trees are sugar maple, and in the regeneration layer, you have 30% of the sugar maple, which is great. So you do have this regeneration occurring, even though there is this dominance of buckthorn and chokecherry, you're still having sugar maple. However, when you're looking at the unfenced plots, what's happening is only 13% of it is actually sugar maple. So even though your majority of the trees in the unfenced are sugar maple, it's not being reflected in the regeneration layer. So instead, the chokecherry and European buckthorn are overtaking the sugar maple seedling regeneration. So this is something that I find concerning and something to be aware of as you move forward with your monitoring. So the next objective of mine was to just do a comparison of the native versus non-native. So all the different species that I showed you guys is basically just grouping them into native versus non-native to Ontario, not just this area. And based on that, in the fence, you see that you have 76% of the tree species which are native, and you have some non-native and some snags because these are the DBH classes, so you would have some species that you can't really account for. And then you have, in the unfenced, you have a lot more native species, which is great because like you're seeing in the sugar maple, there's this large percent of sugar maple. So this is great that in the canopy and the other sub-canopy, you have a large native percentage, but in the regeneration, that's not being reflected. So that is, there's this difference, which is something to be aware of. Next, I did the same type of native to non-native comparison for the seedling layer, and I did them based on the seedling size classes. And overall, you can see that the fenced has this really, really large number of native, non-native species with this really long error bar, which when I looked into it more closely, what's happening is there was one fence plot with crazy high numbers of buckthorn seedlings. There was like 200 seedling in 1 by 1 meter subplot. And that was just an anomaly. I'm not sure what's happening with that plot, but it is that no matter how much you're trying to account for these ecological differences, they will still sneak in. So this is really hard to control for, but overall, if you're ignoring this one, or when you're looking at the other ones, the fenced plots have more regeneration and more more number of seedlings per 1 by 1 meter area compared to the unfenced seedlings on average for almost all the size classes. Next, I decided to do a size class distribution for the species, and this is using all the different tree species that are available in the plots. And this is the pattern that you see. It's a reverse J pattern, and it's found in both the fenced and unfenced plots, which is great because when I was looking at literature, this reverse J pattern is indicative of a regenerating forest. So that's great news that this forests are currently regenerating. So now whether this regeneration is good or bad, it's hard to say because, again, in the unfenced plots, you see that the sugar maples are not really coming back as much as they should be. And last, for the second bit, I did a comparison for the sugar maple as well because that's, again, the dominant species, and you see the same pattern of this reverse J. So the sugar maple is, again, regenerating, but is it regenerating adequately? It's hard to say. So for my last objective, I decided to look at the disturbances between the fenced and unfenced plots. And when these are some of the disturbance types. And when you're looking at it, you can clearly see that the unfenced plots have a greater number and greater percentage of disturbances than the fenced plots. For example, soil compaction, you can see that there is a like 12% disturbance, whereas there's no soil compaction in the fenced plots. So this is something that was very interesting to see, that these disturbances are clearly absent in the fenced plots, whether because people can't access it or whatever the reason is, but there's this clear difference. I also just decided to do a count, a frequency of the different plots to see what's happening. And you can see that, again, you have a lot more of the disturbances being found in the unfenced plots compared to the fenced plots. And for example, this soil compaction especially is very interesting because of the implications it has on the regeneration layer and other vegetation. And these are some other factors that I decided to look at, not just directly related to my objectives, just to know more about the system. And overall, the canopy health, they're pretty similar, which is great to see. So overall, the canopy health doesn't differ between fenced or unfenced. The tree height, again, does not differ between the fenced or unfenced. And again, I looked at the Bryophyte cover, which is moss, and there is a higher Bryophyte in fenced, but not in compared to the unfenced, but it's not significantly different. Lastly, I decided to look at the surface features, and here you said that in leaf litter, you have higher leaf litter in fenced compared to the unfenced. You have higher exposed soil in the fenced compared to the unfenced, and so on. And again, these are not significantly different, but these are features that are currently available in these fenced versus unfenced plots. So overall, what is happening? So from my study, I found that, again, there's no significant difference in species diversity, richness, or evenness for any of the layers, except for canopy evenness. It could just be some random, I don't know what's happening there, frankly, because it's really hard to say about why only that indicator is different. Overall, there's no significant differences in height or canopy health of the trees, and there's no significant differences in the average percent cover of Bryophyte, even though there is a higher average percent in the fenced plots. So overall, this is the main part for the unfenced plots, is that the sugar maple seedlings are only making up 13% of the seedling regeneration, despite it making up 40% of the tree proportion, which is concerning. And European buckthorn and choke cherry are currently outnumbering the sugar maple seedlings in the regeneration for the unfenced plots. In the fenced plots, there is a better proportion of sugar maple seedlings to what's found in the canopy and other layers. Even though there is a large number of buckthorn as well, sugar maple is still having a chance to continue. And lastly, for significant differences, there is a significant difference in disturbance types, and the fenced plots have lower percentage of disturbances and smaller variety of disturbances, and soil compaction is found in the unfenced plots but not in the fenced plots. And this is again important because soil compaction has an impact on what's going to come up in the next regeneration layer and what's likely to survive and so on. So there is something that is currently happening in this fenced versus unfenced plots. So for my recommendations, I wish I could give clear recommendations, but again, my study was not able to answer a question of are these differences due to fencing or not. So I would suggest for them to conduct a study that is more that is suited for answering this kind of question. And the factors they would have to consider when designing this type of study is that they would have to know the time since fencing, because without this knowledge, you don't have a time zero. So currently this is, even if we use my results as time zero, you would have to continue to do regular sampling every few years, so you have time steps and you have a temporal variation so you can see what's happening over a time period. And the plots must be similar as possible, and if there are differences, those differences must be something that you can account for in data analysis. And more than one plot per woodland has to be selected so you have replication. And lastly, even if you're unable to have this study design, you should at least continue monitoring these plots, because as I'm saying, it is kind of concerning that they are not having regeneration of sugar maple, even though these are sugar maple dominated forests. And this, as the disturbances increase, it could have other impacts that you're not currently seeing. As well as because there was a time difference between when they were sampled, we're not able to see difference in the ephemeral plants, so it would be interesting to do that in spring, so you have this difference. And so these are some of my pictures. This is a cool tree. Anyways, so this was a really fun project, and even though it was not always sunshine and rainbows, it rained a lot, but it was still fun, and I'm very thankful to everyone, Danijela especially for giving me this chance, for Sarah for looking after me, my external supervisor who left me. She was amazing, and my field partner, field lead, who kept me from going into poison ivy. Thank you so much, Ian, even though you're not here. And to Dave and Wazel for helping us identify different trees. And Catherine for keeping us on track. I'm done. Thank you. Yes.
Oh, wait. I'm going to jump the queue. I'll pass it out soon. One of your biggest results was the large, like twice as much small seedling regeneration. Maybe it was for sugar maple or for everything in the fenced plots, right?
Yeah, one of them is that sugar maple is not really regenerating as much in the unfenced plots.
And at the beginning of your talk, you talked about fences in terms of people. Mm-hmm. But usually when I hear about fencing studies, it's to do with deer and browsing. So I was just wondering to what extent that is a browsing signal, and basically I'm just wondering how many deer or browsers are there in the area.
That's actually really interesting, and that's something Danijela had also pointed out. So browsing is one of the factors I looked at, but it turned out there was only one incidence of browsing, and it was in an unfenced plot. But because Mississauga is such a fragmented landscape, even if you have these woodlands, they're not close enough and they're not large enough for these deer to be as big a problem as people are. Okay. So browsing could be a problem, but it's not really a problem in Mississauga.
Okay, good. Okay, I thought maybe it was, but it sounds pretty definitive. Where was that hand? Okay. Yes, just in case. Could be.
Oh, sure. Okay, great. When were the fences installed? And how much, do you think that that's a significant amount of time to show any difference in, regeneration patterns?
See, that's the thing. That's the reason that I'm not using this study to say that fencing is causing this difference, because I don't know what time they've been fenced. And this is that information I try to get from the city of Mississauga, but they were saying how this is not recorded in their written data sets. It's something like floating around somewhere. And my supervisor changed halfway through, so she was unable to get this information. So overall, I don't have the answer to that. But that's a consideration I'm definitely worried about.
So this study or this analysis that you did it all happen in one plot? So you were comparing fenced and unfenced plots side by side?
No, they're different.
So how many plots did you use?
I used 22, 8 of which were fenced. And they're located throughout. I don't have a map of which ones are the fenced ones, but they're usually located far away from each other.
So did you do any relative comparison between unfenced and fenced plot that kind of nearby to see if the regeneration or whatever the seedling or species composition effects were similar? Because I would expect plots that are closer together to have a similar species composition or abundance patterns.
I have not looked at distance as a factor, but overall I was trying to account for this difference in ecosystem type in the earlier sections when I was selecting my plots, so that they would all be sugar maple dominated types of forest, so that even if they were nearby or distance, they would have a similar type of species.
Rakika, I really enjoyed your presentation. It was very clear, easy to understand, which I enjoy. So from your study and your results, would you say that it's justified to keep the public off of these properties or lands, and not on any other results, but on what you've found? Would you say that we're justified to do that or not really?
Again, I'm very cautious to say yes or no to this kind of question because this study is not designed for that. But from my understanding and based on what is found, even just looking at the disturbances, I would say yes, it is justified, especially if you're looking at these very, very few mature forests that are still remaining in such a fragmented landscape. If you are able to fence it off to keep the people off for a few years so that the woodland has a chance to continue, I think it is justified, but it is really hard to convince the public of this. And in Mississauga, they have this case of this one woodland that they had fenced off for 20 years, and it was able to recover as a result. So it has been successful, but it's just one of the examples, and they had to fight for it a lot. So, yeah. Here. Oh, there.
Thank you, Rakika. I was just curious about the species composition of your plots. Did you not find any like Norway maple in these plots, or am I perhaps just missing the code?
I think they are there. It's just there's buckthorn for sure. Acer. Sorry, I'm not entirely sure of that.
From your own experience, do you recall the
Nora maple?
Yeah.
They are found in these sugar maple plots, but they're usually not as frequent as the other sugar maple seedlings. And don't tell them if I found any, I took it out. But yeah, there would be a few seedlings that would sneak in, but for maybe in the seed room. Sorry, I don't think it's in the sample that I worked with, but it was in other plots.
Rakika, so one of the human disturbances you had listed was tree cutting.
Yes.
And it looked like I was kind of expecting that one to just disappear in the fenced plots.
Ash trees.
Okay.
Yeah.
Okay, got it. Removals of.
Yeah.
Cool.
Because if the plots are near homes or other, you would have to cut the ash trees.
Got it.
I want to thank you for doing this study. I want to point out that this technique is used in the city of Toronto and the Sherwood Forest, which actually is an old-growth forest, and it seems to have been quite successful. That it actually was community pressure, I believe, on the city of Toronto that led to the fencing, and there is better, tree regeneration as a result. And though I'm not certain of this, I believe it's also in Hyde Park.
Okay.
And I think it should be used more at Brock University, the escarpment. I can see parts of the escarpment forest where there's no tree regeneration, and I have a gut feeling it's this problem of trampling. It might, and the university should study and do test plots. But they took to list of recreational studies professor, he thought it was terrible to prevent people from trampling down the forest. I mean, I hope that your work gets out there and people pay attention to it.
Thank you. And this was something that I found when I was doing my research, is that there's very few literature actually looking at how humans are impacting this urban forest. Whenever they're talking about fencing, it's always keeping the deer out, even though in this kind of urban landscape where the landscapes are full fragmented, the people are causing more damage than any of the wildlife are. So this is very interesting, and there are so many articles that I read that were talking about how fence is considered this invisible part of the landscape that no one really considers, but it has such a big impact, and how people should do studies. So there are more papers telling to do study than there are studies. It's really fun. Any other questions? Well, thank you, everyone.
Thank you.